Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the transformer. We see the definition of the transformer. Transformer is a stationary device used to transform electrical power from one circuit to another without changing its frequency. Transformer is a stationary device used to transform electrical power from one circuit to another without changing its frequency. So, so what's the meaning of transformer? It's a stationary device. It's used to power is transformed one place to another place without changing its frequency. See the structure of the transformer. In this transformer, it contains primary coils, secondary coils. In this primary coils, we have primary voltage and primary current. This is secondary voltage and secondary current. Okay, this is the structure of the transformer. Okay, next, principle to work the transformer. The principle of transformer is the mutual induction between two coils. So what is the mutual induction? Consider two coils like in transformer, primary and secondary coils. In this primary and secondary coils, there is a EMF is generates in one coil. By using this primary coil, the EMF is generates in secondary coil also. So this is the mutual induction between the two coils. So that's when an electrical current passing through a coil changes with the time, the EMF is induced in the neighboring coil. So it's possible electric current passing through primary coil changes with time. The EMF is induced in the neighboring coil. So this is the principle. So what is the principle to work the transformer is mutual induction. Next, working. When AC current is passing through the primary coil, the magnetic flux through iron core changes, which does two things: produces EMF in the primary and induced EMF in setup is secondary. Alternating current is passing through the primary coil, it gives magnetic flux. This flux gives the EMF in primary, induced EMF in secondary. If we assume that the resistance of primary is negligible, then the back EMF will be equal to the voltage applied to the primary back EMF. Okay, the voltage in primary coil V1 is equal to minus N1 into d phi by dt. So here voltage represents the formation of the EMF in primary coil. V2 is equal to minus N2 d phi by dt. Consider this V1, V2 is the EMFs. So this equation represents the law of Faraday's for electromagnetic induction. So that is, the induced EMF is equal to rate of change of flux in opposite direction. Okay. So where N1, N2 are number of turns in the primary and secondary coils respectively, while V1 and V2 are voltages respectively. So N1, N2 are the number of turns in the primary and secondary coils respectively, while V1, V2 are their voltages respectively. So this is the working the transformer. Okay. Let alternate current, alternate voltage, and number of turns in primary and secondary coils are IP, IS, VP, VS, NP, NS respectively. For 100% efficient transformer, we have a relation input power is equal to output power. So that power relation V is equal to W or power divided by current. That means power is equal to voltage into current. Power is equal to voltage into current. P is equal to VI. So by using that relation, V suffix P, I suffix P, that is equal to VS IS. Also assuming transformation ratio of transformer is R, that is equal to Ns by Np, that is number of turns in secondary coil divided by number of turns in primary coil, that is equal to voltage in secondary coil divided by voltage in primary, that is equal to current in primary coil divided by current in secondary coil. So by using this relation IP by IS, that is equal to VS by VP. So here IP is equal to VS by VP into IS. So finally R is equal to NS by NP. So this is the transformation or transformer ratio. This is the transformer ratio. So here we have the another relation, that is for an idle transformer input power that is equal to output power. So Vi or V1 I1 that is equal to V2 I2. V1 by V2 that is equal to I2 by I1. So this is the ideal transformer relation. So in this video we discussed the transformer definition. So what is the transformer definition? It's a device transfer the power from one circuit to another without changing its frequency. So in this transformer, we have a primary coils and secondary coils. We have to correct this primary coils with a primary voltage V of P, primary current IP. Okay. So this one converts to this secondary coil, that is voltage is Vs, current is Is. Okay. Coming to the principle of the transformer is mutual induction. Mutual induction, it's nothing but a induced EMF is generated in one coil by the neighboring coil. So that is the mutual induction. Next, working on the transformer is the AC current is applied to the primary coil. The flux is generated. This flux, this magnetic flux gives the EMF in primary, induced EMF in secondary coils. So assume that this EMFs V1, V2, according to law of Faraday's electromagnetic induction, we derive the equations, that is N1 d5 by dt, N2 d5 by dt. So here N1, N2 are the number of turns in primary and secondary coils, V1, V2 are the voltages respectively. So in this transformer, for 100% efficient transformer, we have the relation input power is equal to output power. At that relation, we have to convert that transformer ratio R is equal to NS by NP and is equal to VS by VP, IP by IS. So finally, transformer ratio R is equal to NS by NP. For ideal transformer, we have the relation in between voltage and current, that is equal to V1 by V2, that is equal to I2 by I1. So this is the information about the transformer. So transformer, it's nothing but a device to transfer the electrical power from one circuit to another circuit without changing the frequency. So thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.